Okay, so I think most of you heard the recap on Friday. This will just be a little bit more in depth, and it did give me a chance to think about how to talk about some of the subjects in a better way. Um, of course, this particular work stream was organized by me and Thomas. We I guess we had about 20 people throughout the day, and very lively conversations, which was fantastic. So I definitely want to thank everybody who attended and participated. I feel that we made great progress, and I'm certainly convinced that an open collaboration like this is critical for us to accelerate the acceptance of quantum systems in HPC data centers. Okay. All right. Um, and again, thank you to our fearless leader, Amir, for pulling everything together. And I don't know, did you leave the office Friday, Amir, or did you just stay there and are you still pulling together all presentation?
I folded my
Yeah.
mattress. It's in this office next door.
Yeah, that's what I expected. Right, right. Okay. Yeah. So yeah, he worked tirelessly to pull all the leads together. Um, and yeah, thank you. It was great. Okay, so the goal of the work stream is that we do want to establish a standard community-driven management interface, okay, to integrate quantum systems in HPC data centers. This is the ideal. We we certainly do not expect to have that by this year, but we do believe we're making progress in defining how we will get there. And it's a pretty well-worn, well-used methodology. We listen to the stakeholders, then we go implement APIs or propose APIs to meet the requirements, and then we come up with experiments to evaluate this. And Friday, we were quite successful, I think, in creating milestones, publications, and other artifacts. In fact, I think we were so successful that I've asked the leads to, or the owners of the milestones to please make sure that that they're realistic, right? I think it's good to set very high goals and and set high expectations, but of course we also want to be realistic as well. Okay. All right. Let's move on. This was something I showed at the beginning because I did want people to understand why they were there. Um, And of course, since this work stream was about quantum resource interfaces, we are at the center of the universe here. And the two main projects that are working on this are at the center of the universe, QDMI and QRMI. We sit on top of the quantum systems. Then we have the stars floating around us, applications, SDKs, compilers, workflow managers, workload managers, operations teams, analytics and monitoring teams. I think it was Doug who astutely pointed out that there should be lines between the stars. But I said for my response to that was for the purposes of our conversations, we're the only ones that really matter. So the relationship to us is the only one that really mattered. Okay. Any questions about what I've been saying so far? Pretty straightforward, I think. All right. Okay. So our format was a series of lightning talks. Well, some of them weren't as fast as lightning, probably more like molasses, but that was okay because they were very good discussions. I would definitely say our nomenclature talk went on a lot longer than I scheduled for. I should have known better that any discussion about nomenclature when you bring different people together who have just newly met will take a while. But that's okay. I think that we came to good agreement about our vocabulary, which is nice. Then we discussed the current state of quantum resource interfaces. And this came from 3 sources. I want to thank Matthias Taub, who represented QDMI. Lucas was also on the call, and he filled in gaps as well. He was quite helpful. Calling from a train somewhere in Germany. I was quite impressed. He was able to do that. Munetaka Otani-san covered QRMI. And then we had Doug Uterik, who is pulling together QFW, which is, let's say it's sort of the instantiation of the openQSE specifications. And he described the work that is setting up the test bed to compare QDMI and QRMI, among other things. QFW has a much broader purpose, but we are using it to compare the 2 interfaces. Right. Then we heard from the stakeholders. It was great having the workload manager developers in the discussion. We had Doug Jacobson from NVIDIA and Slurm. Actually, yeah, Doug, do we refer to SCED-MD anymore, or do we just say NVIDIA? That was a question I had.
It's actually very acceptable to say SCED-MD when referring
okay.
to the Slurm development part of NVIDIA.
Okay, all right. I will keep saying SCED-MD then, because I've said it for many years now. All right. We had Cameron Bruner from PBS. We had Gabor Samu from LSF, and we had Vanessa Sochat from Lawrence Livermore tell us about Flux and some scheduling work that she's been doing. So it was great talking with them, getting their input. We were hoping to hear from other work streams, but that didn't quite work out on Friday. That's okay. I think that will happen at some point. We also heard from the HPC operations team, Michael Sandvadal. Unfortunately, we had to cut out analytics and hearing from the analytics and monitoring team because we ran out of time, but we will pull him in into future discussions. Okay. We did ask each speaker to leave ample time for discussion. And as we were talking, we were creating the milestones, publications, and artifacts. Okay. Any questions so far? All right, great. So this was our overly optimistic time schedule. But in the end, it actually turned out okay because the only thing we dropped was the final time slot. Okay, and it worked out somehow. Okay. All right. So just to go into a bit more detail into each of the sessions, Otani-san led the nomenclature session, and I think it was nice because he focused on how quantum systems operate and interact with HPC environments when he was talking about things like what is a quantum resource, or what is a workflow, or what is a workload manager. This was nice because it sparked a lot of discussion. We did come up with some formal definitions, but I think what was the ultimate outcome was everybody at least coming to agreement on what we are dealing with, okay, as opposed to strict definitions. I don't have his slide deck handy with me, but I do promise to that I will share that so other work streams can take a look at the definitions that we did come up with. Okay. QDMI. As I said, Mateus brought us up to date on what QDMI will be doing, and really their focus is going to be on modularity. So what they're finding is that within the larger resource management interface world, they can define a core interface, okay, and then have what we would call extension modules. Okay, so for example, the core interface would include things like really basic and fundamental things like session management, authentication, and then the extension modules would include things like specific vendor definitions or vendor modules. Okay, so we think this is going to be exciting in the future as the interfaces start to mature. So we would definitely like to track that and understand where they're going. Okay. Would anybody from the QDMI team like to comment more on this? Okay, we can move on. Then we discussed QRMI, or where QRMI is going. And Otani-san explained that our focus going forward will continue to be on workload manager integration. That has been really our focus from the start. We really want to understand, for example, is QRMI agnostic to the workload managers? If not, what are the sticking points that do not make it agnostic? So going forward, we want to focus on issues that are related to the integration, such as resource discovery, accounting information, and credentials management. Unfortunately, during the work stream, we didn't get a chance to really dive into any of these areas, but we're looking forward to talking with the workload manager developers more about these topics in the future. Okay. Let's see. Then Doug, he gave us a deeper dive into QFW. The comparison between QDMI and QRMI is almost ready to start. He's convinced that the stack is working in containers, and now he just needs to attach everything to a real system, and that real system will be IQM. He kept saying that it's Amir's fault that he can't connect to IQM, but hopefully they'll be able to get that sorted out soon so that we can start collecting usage pattern data. Okay. He also let us know that they are beginning to think about transport benchmarking and schedulers. The transport work is interesting because he comes from a libfabric background, and he started to think about what if you want to plug in different transports to carry information between the quantum systems and the workload managers. So he put together somewhat of a framework to allow you to do that. Now, will we actually need that? Well, we're not sure at this point, but it's we're putting it as a possibly nice to have. Okay. With respect to benchmarking, Doug realized that because QFW is kind of a glue between the layers of the quantum HPC software stack, it's a really nice place to collect data about the different layers. Okay, so he started to think about what kind of data to collect and how to store it. And we think that this could be quite valuable to the effort going forward as well. Okay. Amir or Doug, would you like to explain the scheduling work? Because I'm not sure I fully understand it.
That's on you, Amir.
Sure. The scheduler is basically like it should be under the QRMI. QDMI is like a device scheduler, so it's analogous to like a CPU scheduler. It gets the quantum tasks and then decides how to execute them, because you can be getting quantum tasks from multiple different jobs that are concurrently using the same machine at the same time. So this is not like a brand new idea. For example, in Quantinuum's talk, they had the same sort of concept on their system that's deployed currently at what do you call it, in Japan,
at Recon.
At Recon, right?
Okay.
So it's basically the same idea. We're just saying, okay, instead of having it being vendor specific, why don't we just make it as a common module that people can use?
Okay, great. Yeah, so these are additional things that that we know about that QFW is working on or is pushing forward, in addition to being a nice framework for us to compare QDMI and QRMI. I don't think we really want to describe it as comparing them. I think a better description is more that we are trying to understand what the right interface is. And one way to look at how Doug has done the integration, or putting them side by side, is he's kind of taken the union of the interfaces. Doug, would you say that's fair?
Second, that's exactly what I've done. Is I went with the union and trying to come up with a common interface that is got that union, with each side nulling out the calls that it doesn't implement yet. And then this kind of highlights the differences. And if a user wants that particular functionality, then it puts the onus on the side that's not implemented it to maybe consider doing that, to come up with a more comprehensive approach that these libraries have, that the upper layers can depend upon consistently being there.
Right. Okay. Thank you, Doug. Any questions about these sessions? All right. This was perhaps one of the most interesting sessions because, of course, everybody wants to understand what Slurm is doing and where it's going. So Doug, I mean, if I mischaracterize anything that you've been saying, you said, please let me know. Okay. But one of the kind of surprises we had is that Doug was telling us that the Spank plugins, which is actually the most popular way that people are using, we do it, QMI does it, QDMI does it. Other people are doing it to connect quantum systems, into the Slurm framework, into the Slurm workload manager. They are being increasingly viewed as maintenance and support burdens. So Doug recommended that we avoid Spank plugins and switch to something called HRES. And HRES will replace the dynamic licenses, but it will also add some things. Most important to us is adding the ability to install plugins that can be used to check the state of the quantum systems. We have been finding this to be very important because quantum systems are much more dynamic in nature than CPUs and GPUs. There was a bit of a discussion about the choice of the deployment language. According to Doug, HRES will rely on Lua, and the claim is that Slurm operators will favor Lua because Lua will just come in text files because they're scripts, and should be more operationally approachable. I'm not sure that's actually a phrase, but I hope you understand what I mean. The concern that popped up during the work stream is that to really work with Lua, you have to install other packages. So does that reduce some of the benefits associated with Lua? I think it's going to be interesting to find out. Okay, so Doug, would you like to correct me or add any color to that discussion?
Just a little tiny bit. First off,
Okay.
I just want to say we're not reducing support for Spank in any way. So very specifically from some of the quantum vendors, we've received requests to review their specific Spank plugins to somewhat give us a stamp of approval. And then that will be coming. So we view Spank as something that is an amazing tool that is absolutely fantastic for site administrators to work with. The goal here with Aitra is to produce something that vendors can more adequately build a support model around. So I just like draw that distinction that the Atra's plugins will give the quantum community a way to distribute this wider base without necessarily getting involved in sort of development. Whereas Spank is very much a site administrator space, if that makes sense.
Okay, I will change the line in this slide to say avoid developing new Spank plugins to consider HRES for quantum resource management. So I'll leave out the avoid.
We're trying to give you we're trying to give the community a production level way of managing this rather than sort of interleave yourselves into individual sites that needs.
Okay, great. Okay. Thanks, Doug. Yeah, that's definitely a very subtle, but an important point. Yeah. Kevin, I think you had your hand up.
I just want to underscore the point that Doug just made there. I mean, if HRES is what you want to do, I mean, HRES is what we can upstream, basically. And it becomes a base on which lots of people can build. Spank ends up is just basically locally scoped in a certain fundamental way. And so if we can do this, I'm not saying it's easy. It's not the easiest thing to do, but it's the stickiest thing to do.
Okay, fair. I think that's a fair statement, Kevin. And we're definitely excited to try it. In fact, that was one of the things that came out of the work stream. Yes, let's. Otani-san is very keen on giving it a try.
Let's see what problems we run into, but it should be straightforward.
Yes, I agree. Amir, you have your hands up.
Yeah, so I will just kind of clarify the point. So HRES, you still have to create like a plugin written in Lua, right, in order for it to interact with a quantum resource. So is that plugin going to be upstreamed or is it going to be local to the site?
It's something that this project, for example, could distribute, or IBM could distribute, or others could distribute. We sort of be willing to put things for contributor space. But the idea here is that the issue with a C-based plugin is that it gets very tied into the features with a specific version. And so the Lua meta table capabilities allow a much more stable ABI between versions. So it becomes something that where your development velocity isn't tied to our development velocity, and you're not constantly trying to react to things that we've done and so on and so forth.
Got it. Okay, thank you.
Yeah, that was the point I was trying to make about operationally approachable, that it makes life easier for operators, or at least that's the theory. Okay, thanks, Doug. Yeah, and we're looking forward to working with you on this. Okay. All right. Okay. The next sessions were about Flux and PBS. Vanessa Sochat gave us an overview of the activities with respect to Flux. So they demonstrated a solution to what they call the 2Q problem, using their graph-based scheduler Fluxion on top of Kubernetes. They decided to go with Kubernetes initially because it's an easier development environment for them. The 2Q problem is the fact that when you submit jobs to, say, Amazon Bracket or IBM Quantum Platform, you are dealing with a queue that they provide that you have you have very little information about. You don't know when you will actually run. Okay. If at the same time you have another queue of jobs that need classical resources, it's very hard to understand then when you should be allocating the quantum resource and the classical resource, when that should happen. So they came up with a pretty interesting solution, very practical solution. What they do is that they monitored the queue that they have no transparency into. And when it gets down to you being the next job to run, that's when they allocate the classical resources. And they ran some jobs and gathered some numbers and showed that this significantly reduced the idle time of the classical resources. Oh, Kevin, you had your hand up? Oh, you were clapping. Oh, okay, I see. Okay. Yeah, they are transitioning this work over to what's known as the Flux core. And this is not Kubernetes. It's what you can run as a supercomputer level scheduler. They do use the Flux core to run. Oh, I'm drawing a blank. What's the Livermore version of Frontier? El Capitan. Sorry. Okay. I had a little bit of a brain fart there. They are using it on El Capitan, but you could also use Flux core on top of Slurm as well. Okay. They have also been very interested because Vanessa has done quite a bit of work in workflow tools or workflow managers. They showed us a demonstration of QRMI that was integrated with SnakeMake, which is a workflow tool. So we're certainly looking forward to continuing to work with Livermore in this area. Then Doug gave us an overview of the PBS activities. One thing that they are considering now is this concept of pooling QPUs and then trying to understand how to match the jobs to the right QPUs. I think it's very similar to the resource discovery problems that QDMI and QRMI are already facing. Like, how do you match a job to a particular QPU? Then they also explained to us that the approach that we're taking to integrate QRMI with PBS has some scalability concerns. Well, actually, we identified the scalability concerns with them while we were doing the PBS integration. But Doug actually has some alternative approaches that we could take, but unfortunately, we weren't able to dive into deeper exploration. By the time Doug started talking, I had to limit everybody to 10 minutes, virtually. One nice thing that came out of side discussions is that they will offer evaluations license for the full production suite to the QRMI community. I assume that this could be extended to the QDMI community if the QDMI community also wants to integrate with PBS. Okay. All right. Any questions or comments about Flux or PBS? Oh, Amir, go ahead.
You mentioned that the matching a job to a particular QPU, the QPU pooling here. Mm-hmm. And then you said QRMI and QDMI are doing that. Is that the right place to actually make that matching in the QRMI and QDMI layer?
Yeah, that's a good question. So what our current thought in the QRMI community, and I should let the QDMI community speak for themselves, is to provide a vendor neutral resource discovery interface, which would allow the workload managers to take advantage of the different hardware that's being provided. But of course, you can push this up into the workload manager layer as well. So it's an active discussion, Amir. Yeah. Okay. Fair point. Oh, sorry, Jerry. I didn't realize you were one. I let Amir sneak in front of you. Apologies.
Oh, no worries. Could you talk a little bit more
Mhm.
about the Fluxion Kubernetes integration? Is it a replacing of the Kubernetes scheduler with Flux, or what is
Correct.
the intent? And okay,
Yeah, exactly. Yeah. So in fact, this is my first interaction with the Livermore Flux team. They have been interested in what they call converged computing for some time. And when I started interacting with them, the two converging computing technologies were AI and HPC. And they put Fluxion on top of Kubernetes because Kubernetes does a great job of managing AI workloads. And they were able to show that it can also manage HPC workloads too with Fluxion. We do actually have another Kubernetes integration with QRMI that uses the default scheduler. But of course, that is much more limited than what Fluxion can do. But we wanted to show it as a proof of concept as well. So does that
so
answer?
no, this is good. So basically, right, Kubernetes, the philosophy of the Kubernetes scheduler is slightly different from, I don't know as much about Flux as I know about Slurm, but basically the idea is that there are different principles of scheduling HPC resources that are sort of CPU and other resources in Kubernetes. And the idea is to bridge those two because Kubernetes is a widely used infrastructure for deploying workloads, AI, CPU based. And so is it the right kind of am I on the right track?
I would say yes. They wanted the Slurm approach, and I assume you're talking about Slinky. Okay.
Yep.
Has it works, but it's not really integrated with the default scheduler or DRA or anything like that. What the Flux team really wanted to have was a scheduler that understood how to manage both and schedule both natively. So, maybe Doug will correct me here. Doug, go ahead.
No, it's no worse. I didn't happen to highlight Slinky too heavily in my presentation. Just wanted to point out that the term bridge was helpful. The Slurm bridge portion of Slinky does indeed also provide direct scheduling capabilities from Kubernetes.
Oh, great. Oh, great. Okay.
I'm not trying to steal their thunder. I just wanted to address that specific point.
Okay, yeah, it's been a while since I've looked at Slinky, so I was afraid that I might be misspeaking because I'm sure they have been hard at work as well. So okay, all right.
I think the
go ahead.
Siemens, his name is Cameron Bruner, right?
Oh, Cameron Bruner. Oh, I will correct that. I don't know how I got Doug Cameron. Maybe I was thinking of our two Dougs.
Too many Dougs.
Doug Jacob. Yeah, too many Dougs. Yeah.
We have a second name that has two. We have a full house.
Yeah.
Sorry.
Okay. Yeah. No worries. Okay. Yeah. Thanks, Amir. Okay. All right. Then we wrapped up with LSF and ORNL operations. LSF explained that they have demonstrated an SQD workflow. And Amir, to your point, they provided resource discovery at the LSF level using the same API that Qiskit uses. on their wish list is accounting information and understanding when tasks will finish. Okay, and these are very reasonable. This is a very reasonable wish list. These are things that we're working on actually now as well. The ORNL operations was a real eye opener. Because Michael was explaining to us that for quote unquote acceptance, like, full acceptance into their operations, there's a whole host of issues that have to be addressed with respect to operator requirements and user requirements, training requirements, and things like that. So we definitely want to continue talking with the ORNL operations team to understand those better. Right. Any questions? Okay, great.
Do you think it would be useful? Sorry. Do you think it would be useful to have them give a talk on the Monday meeting, just to cover? If was it a long enough discussion that would benefit everybody?
It might. Yeah. Let me get the thoughts from the work stream meetings and get back to you on that, Amir. Okay.
Sounds good.
Right. Okay.
You
Yes.
I also wanted to mention we wrote a paper essentially summarizing that it was like a lessons learned of the quantum computing user support and operations over the last 4 years. It was submitted as an SC paper, didn't quite make the cut, but we're resubmitting it as a workshop paper. So at some point soon that'll be on the archive, and that actually I think would be Michael's presentation will be his own, but that would be kind of a nice companion to that.
Oh, great. Okay. Fantastic. Yeah, we definitely would like to understand both sources better. Yeah, Michael's presentation and your paper. Okay. Are you allowed to share that paper, Ryan, or not?
I am submitting it to the workshop on August 7th, so I assume it's going to be going on the archive almost simultaneously with that. And at that point, then yes.
Oh, fantastic. Okay. Thank you for letting us know about that, Ryan.
Sounds
That
good.
could also be a talk, a discussion point, Ryan, if you'd be willing to present that at some point.
Mm-hmm.
It's I'd be happy to. I'd want Michael and or Jordan to be there just because this is it's a paper about my former role. So they represent current operations, and it's evolved, and that's the issues and aspects of operations that are evolving past the cutoff point that was included in my paper. They may want to be the ones to present on, but I'm happy to.
Okay. Fantastic. Okay. Thank you for bringing that up. Okay. And good luck with the submission. All right.
Thanks.
Oh, sure. Okay, so this is the list of milestones, papers, etc., that I collected during the discussions. And I shared it with everybody during the readout at the end of the day. When I got back to my hotel room, I realized, how did anybody understand this? Because it's just a lot of text. So what I did was I created this slide to hopefully try to better explain how I think the work stream is moving forward. I would like to think of it in terms of 3 threads. Okay, at least after this particular work stream discussion, we may be adding more threads as we continue the discussions, but out of the Friday discussions, I think this is what we have. So I think we have a thread with respect to workload manager integrations. We want to take the current integrations and start addressing issues that we've seen. Hopefully Slurm HRES will help us with that. The Flux team is continuing to work on these issues as well. And Cameron would like to help us with the scalability issues that we identified. Then what I think should be sort of a final output for that is a nice quantitative paper about integrations. Okay. And with respect to the workload manager integrations thread, I think this is where we really need input from the system architecture and workflows work stream to tell us what type of requirements they see. Okay, and at some point, we do want to start looking into workflow tools and managers. I don't know right now if this is a separate thread or part of this thread, but we'll figure that out as we move along. Okay. Then of course we have another thread that revolves around the QFW testbed, which will manage an IQM system, a real live IQM system. The first goal that we have there is to understand usage patterns. Of course, then write a paper about that, document that, and what we hope is that we come up with a nice openQSE QRI specification. Okay, and then eventually, of course, write a paper about that. I think in parallel, we will be working on the transport scheduler and benchmarking as well. I'm not quite sure about the next steps with respect to that subthread, but we'll figure it out as we move along. And then the final one is the operations, analytics, monitoring requirements. I think we should come up with a document. Maybe it's Ryan's paper. Maybe we could just use Ryan's paper and supplement that. I think that we need to kind of share that with other work streams, get their responses, and that definitely will feed into the QRI specification. Okay. So these are just sort of tentative dates. In the milestone chart here, I did attach owners to each of the milestones, papers or artifacts. And I did ask them to please think about, are the dates realistic? Because the collaboration will only work if the priorities that we define within the collaboration meet their priorities. So I want them to let us know if those dates are reasonable. Okay. All right. So that will. Oh, go ahead.
Can I have some comment?
Suji?
Yeah. So actually, that in our project we have introduced the PSD sub, which is developed in the ECP project between the workflow manager and job schedulers to hide the different interface of the job schedulers. But that now ECP project has been finished and PSD abstract layer will be not maintained well. So that we decided to move something new. So that I think it may be a good idea to add a new topic, abstract layer of the job scheduler between workflow manager and job schedulers.
Oh, sure. Okay. I wasn't aware of this. Could you send me a quick email that describes your thoughts on this, Iwako?
Sure.
Okay, great. Thank you. Appreciate it. Yeah. We talked about the interactions between workflow tools and workload managers. The workflow tools will coordinate the different components of a workflow and then chop things up into jobs that the workload manager will then schedule. But we did not talk about specific interfaces. And so I think I think what you're talking about would be quite valuable. Yeah. Okay, thank you. Okay, so that's all I have, Amir.
Thanks. I have maybe a few questions, or like questions/suggestions. Requirements.
Sure.
Do you think it's useful to have a requirements document because we're collecting all those requirements from the different layers, from the workload manager, from the workflow manager, from the compiler? All these, would it make sense to create a requirements document that we maintain in the open the repos, just so that we can know that eventually if somebody creates another implementation, at least they match the requirements that have been collected?
Yeah, I was kind of struggling with that. If this should be a separate thing or part of the QRI specification. Because I could see it being a separate thing, but I don't know if the QRI specification will cover all the requirements. So I wanted to take a stab at least documenting what we think the requirement before making that call. Does that make sense? I'm kind of hedging here.
I think if we can keep the requirements, because we're already collecting them, so if we have some place where we put them, and then eventually if the QRS specification just covers all the requirements, we can get rid of the document. But if it becomes useful, I think that's what you're saying, right?
Yeah. Oh. Now I know what you're talking. Right. Okay. I know the page that you're talking about now. Yeah. So right. So I guess what the exercise we have not done is mapping those requirements into specifications, into the interface specification. So we need to do that to see can it be folded or not folded.
Yeah, we don't have a specification yet, right? We just know we need to support X, Y, Z. I think it's just useful to kind of collect those set of requirements and keep them around so that we don't forget them, because as you're going through, there's a lot of them, right?
Yeah, true. Okay, yeah, I agree. So maybe I could change this box to add to our existing requirements document.
Yeah, or create a sub one or whatever, something, just so that we can keep track of it.
Yeah, makes sense. Okay.
The other thing about the nomenclature, it seems that it's good to actually document that and keep that as well, and share it with the other work streams so that we can have a common understanding. Because if, for example, if you define what a quantum resource is, that's also valuable for compilers, and that's also valuable for system architecture, and maybe other people have different ideas that to share there. So it would be nice to have that. I'm not sure if it will be a good paper output or something that we can keep around in the repository.
I think it should actually preface the requirements, Amir. Right.
Makes
so
sense.
I think because we will be using the terminology or the nomenclature in the requirements. So yeah, let's document it there. Yeah, if that's okay with you.
Yeah, perfect sense.
Okay, great.
The other thing, maybe just a slight thing, is that right now, whether we use Spank or HRES or any other ones, it seems like we're going to have multiple of them, because HRES or Spank will be calling QRMI specific APIs, and it'll be calling QDMI specific APIs, and it'll be calling, I know IonQ is creating one, for example, as well. So it seems like there might be a good idea to try to, as a low-hanging fruit, try to kind of standardize or kind of have a common plugin, that so we don't have multiple different plugins for every incarnation of an API. Does that make sense? Or
I'm not sure that that could be possible, because names are different. But are you talking about, for example, a Spank plugin that would have if you're using the QDMI library, make these calls?
No.
Or
I was going one step further. If the APIs, if we can come to agreement of what those reservation APIs that get called by the plugins are, that might be a low-hanging fruit that we can, or a motivation to kind of at least come to an agreement to a subset of the APIs that reserve systems, right?
Oh yeah, sure. So I suspect the low-hanging fruit will be things like session management, right, or authentication. Yeah. So there, I think we could. Yeah, we could.
Okay.
Yeah.
That's I guess that more implementation, but we have that Slurm virtual environment for testing. It will be nice to get a Flux one and one that has Flux running over Slurm. That will help us to test some of these things.
Okay. I do know that they have an allergic reaction when you say Flux over Slurm. But yeah, we could certainly talk about that. Yeah, with them.
Thank you.
Yeah, because of course they want to be the native scheduler, but
no. But I thought you said we can have like a case where you have Flux on top of.
You can, yeah. So what Flux would do is then take resources from Slurm, right? Take nodes from Slurm and do the scheduling on top of that. Yeah.
Okay. I was wondering if we do want to test that environment, that might be nice to have like something to test it on.
Yeah, Kevin just made the point that just because it's possible doesn't mean it's a good idea. So thanks, Kevin. Thanks for your support there. Okay. Yeah. Yeah. They do offer a container environment, but I don't know when the QRMI integration will be completed. But so we'll definitely keep an eye on it. Yeah.
Thank you.
Back quick to the Flux and Slurm. I mean, Flux over Slurm is actually the way Flux was run originally, right? So that's easily possible. The Flux is then just a user level scheduler.
Oh, yes, that's correct, Martin. Sorry, I was having cognitive dissonance because you came across as Laura. But,
sorry, yeah. we just on one mic.
Okay.
Sorry about that.
Yeah, no worries, no worries. Okay. Okay, any other questions? Okay, thank you for listening, and thank you for the great feedback too. I'll definitely make modifications to my slides. And I saw that Owako had to drop, but yeah, I'm looking forward to seeing that interface from her too. Okay.